Hello guys, welcome to my channel. Our today's topic is Generative Adversarial Network, in short GAN. It's a really interesting uh, neural network. It's really a useful neural network that's pretty much used in various different applications, but I want to share that most useful application of GAN is uh, face generation. I am actually sharing a website link. There is this person doesn't exist.com. You can check that, go there. Each and every face is generated through this model are not a real face, and you can see their expressions there. Actually it's a really pretty good example. Okay, you can directly check in this link. Now if you look into this GAN model, you can see that it have two network actually. So one is discriminative and another is generative. So uh, the basic thing of, say I have a model of say I have a model and I name it generator G, and here I have another model that is discriminative, so I named this as a D. Now what happened here, that this generative model is actually work like a criminal, okay, and this discriminative model is worked like a police. So it's randomly try to generate some images, and the job of this discriminative model is to identify real image or fake image. So basically if you check the diagram of this network, for this we are supplying some noise actually. So here I have a noise, okay, and here I have this generative model. So this is input, and this is the input. And this actually generate a image. Now this image is actually going to as an input in this discriminative model, okay. and this is generate the output. So if I say that it's a function of z, then this discriminative is dz of z. The purpose of this model is generate some images or some information, and this is like to identify that the information is fake or real. Now we need to check that how it's actually work. Okay, how it's generate a image, how this discriminator is catch the image is correct or not. Okay, so first let us assume that we have a matrix, okay, data matrix, say we have 4x4 matrix, okay, and for this 4x4 we have some real images. So real images, I can say that if I draw a 4x4 matrix, so here I can say that the value is 2, here the value is 2, here the 0 and 0. For the next I can draw another one, and I marked it as a 2 1 0 0. And for here I can 1 1 0 0. So say these all are the real images, and for the fake, say I have data looks like 1 0 to 1.5. and here I have 0 to 1.5 and say 2. So these two are the fake images. Now if you consider the mathematical operation for a generator, okay, so so now if you look into the mathematical operation of a discriminator, I can say that So here we can see that if I take the first one, so our value is 2 2 0 0. So these corner are really high for each and every, okay, each and every matrix. So if from this matrix, if I try to build a network, then it's look like so these two are really high. And I have these two where these two are low. Basically from here we are using a sigmoid function, okay. So now what happened, if I take for these two positive, the weight is +1, and for this the weight is -1. Now the operation actually look like 1 star 2 plus -1 star 0 plus -1 star 0 plus 1 star 2. So this is 2, all these are 0, and this is 2, so it's 4. Now similarly for a fake image, the calculation is become like this. Say our first is 1 0 2 and 1.5, okay. So in similar way, if we calculate, the output become 1 star 1 plus -1 star 0 plus -1 star 2 plus 1 star 1.5. These generate 1, these generate 0, these generate -2 plus 1.5, so it's generate 0.5. So if I use this sigmoid, then if it is greater than 1, then the output is 1. If it is greater than less than 5, so the output is 0. so it's detect that it's a fake image. Okay, so this is the basic calculation of a discriminator. Now if we check that how the generative model is actually working, so for a generator we actually need some random function. Okay, that is one input. Okay, that's a z. Okay, so we have random z as an input. We have bias 1, say here. Now imagine that what we want. If we need some output that looks like this is positive, and these two are negative, so for that we design a node here and here that's take positive. Okay, so we pass these two with plus 1 weight. And this also positive. Okay, this also become positive. Now for these two actually we design a node, those are generate negative. Sorry, so all these green lines are basically negative. And practically all these are like sigmoid function. Okay, so if you do the similar calculation like above, then if I can say that my randomized function z is generate say 0.8. now if we do some calculation, okay, so for this first node, so what we get based on this randomized function, it's 1 star 0.8 plus 1 star, this is my base is 1, or I can say that my base is 2. Okay, basically I start with 2, so my base is 2, so 2, so we can get that 0.8 plus 2, so it's 2.8. now if I pass this 2.8 to a sigmoid function, it's near to give me like 0.94 kind of value. Okay, so for this the output become .9. It's also similar, the second one, it's 0.9. now calculate for the negative one. Okay, so if I calculate for the negative, so it's become -1 star 0.8 plus -1 start 2, so it's become -2.8. okay. So similarly, if I calculate for -2.8, the value of the sigmoid is become 0.07 kind of. okay, so I can say that it's 0.07 and 0.07. okay, so all are less than 1, and it's near to 1. okay, now to make it proper 1 or proper 2, we need to do some back propagation to adjust this weight. And for all of these tasks, actually we need that cost function. okay, and in here I can say that basically we are using log error function. okay, and the logarithmic base value on e. okay, so for discriminator, the log function is minus negative logarithm. okay, ln and prediction, and for this generator it's 1 minus prediction. We are doing this because here what I want to predict, here actually I want to predict that image is right or not, so it's a level 1. okay, so positive. okay, its level is 1. so for 1 if my level is 1, I can easily go with this logarithmic function. okay, and if I predict 0, then this function is appropriate. In my next video, I will share that how you design this model using TensorFlow. This is the basic calculation of this GAN model. Please like and subscribe my channel. I continuously try to give you different kind of videos based on different kind of technology and knowledge, so that it will help you to design different kind of project or improve your technology stacks. So please support me. Thanks for watching.